Okay, let's have a look at this question. So what we got here, we got time t equals 0, particle p is moving origin with speed 2 meters per second along the x-axis in the positive x direction. So it's doing that, t equals 0, 2 meters per second. Just write down your thoughts. At time t seconds when t is greater than 0, the acceleration has this magnitude and is directed towards O. So what does that tell you? It's directed towards O, and therefore it must be what? It must be negative. Okay, so it has magnitude that and directed towards O. Now, if t is bigger than 0, this is always what? This function? Positive. So therefore we know we need to put a minus in front of this, okay, when we're dealing with it. So basically our A will equal minus 3 over t plus 1 squared is the key starting point, and you probably tripped you up to start off with. Okay, so we want to show that at time t seconds the velocity is equal to this, and you had a go at that. You've integrated, you've got that, and then yes, because you've got a minus sign here and you're wondering what the heck do I do to get a positive sign, aren't you, on the function? Well, you see, if you start off from a negative, then that will solve your problem, won't it?
Why is it negative again?
It tells you here that it has magnitude this, so that's okay, and it's directed towards O. Now what I did was a quick check in my head was to what happened, like t equals 0, so t is greater than or equal to 0, what's this bottom bit going to be? Is it going to be positive or negative? It's going to be positive. So this whole thing is positive. Now if it's directed towards O, we know that it's got to be negative, because we're told, well, it depends on what you do. I mean, it says t equals 0, p is at the origin moving with speed 2 meters per second along the x-axis in the positive x direction. So that's decided to be positive direction. So therefore, if it's going towards O, that's the negative direction. Okay, and it's quite important you understand the difference between positive and negative directions when setting up your question. So if you were to integrate this, so you get that. And then we'd get, so v equals, it's going to come from, what's that, 3 over t plus 1. And you divide by minus 1, you're going to end up with a plus there, so plus c. And you know that when t equals 0, v equals 2. So we've got 2 is equal to 3 plus c, so c is equal to minus 1. And you can see why, therefore, it gives you this answer. Okay. Any questions? So he wants to find the distance from P when O when P is instantaneously at rest. What would we do here to start with? What's the first thing you're going to do? Because this is a 7-mark question. What's the first thing you're going to do this question? Make v equals 0. Good. So you make this equal to 0. And what does that give you? The time when it's at rest. So you get the time when it's at rest. Then what are you going to do? How are we going to find the distance? Yeah, you're going to integrate the velocity. So you can find the function of t that gives you your displacement. Okay, and then you can put in the value of t you found when v equals 0 to find the distance from p when it's instantly at rest. Now, how would you find your plus c for this question? We found the plus c previously of using t equals 0 and v equals 2. What's our conditions for the plus c for displacement, looking at the question? Yeah, you got t equals 0, the particles at the origin. So therefore you know that the x equals 0 and t equals 0. Okay, I'm not going to show you how to do that on video. I've given you all the resources you need to do that. Okay, stop recording on that one.